we have to solve for x, a variable in the denominator. We're going to start by cross-multiplying. That means x times 3.4 is going to equal 12.0 times 0.100. I've rewritten that over here. Note that I keep these zeros. I retain these zeros. Don't drop them as you're working through the problem, as if you drop them, you lose your cues as in terms of significant figures. These zeros are trailing zeros in a number with a decimal point. They are significant. Don't drop them. Otherwise, you're going to have a tendency to get the number of Sig Figs incorrect. The next step is I want x by itself on one side of the equation. I achieve that by dividing the right-hand side of the equation by 3.4. That causes the 3.4 to cancel out. Of course, I have to do that on the other side as well. And that yields x is equal to 12.0 times 0.100 divided by 3.4. We'll go ahead, write down our calculator answer. Both numbers in the numerator have 3 Sig Figs. Each of them has trailing zeros and a number with a decimal point. So 1, 2, 3, 1, 2, 3. Remember, this leading zero does not count as significant. In the denominator, there are 2 Sig Figs. So it's the number in the denominator that's going to limit the Sig Figs in our correctly reported answer. The first number we drop is below 5, so we round down, which means we drop all of those numbers. And our correctly reported final answer is 0.35. Quick review of Sig Figs. The number 800, as it is expressed here without a decimal place, is ambiguous. Trailing zeros and a number without a decimal point are ambiguous. In the next number, we see that we have 8 Sig Figs. All the digits 1 to 9 are significant, and these zeros are captive zeros, so they count as significant. In C, this leading zero does not count as significant. The remaining zeros are captive, so they do count as significant. So we see we have 1, 2, 3, 4, 5, 6, 6 Sig Figs in the number in C. In this number, we see that there is a decimal point in that number. So the zeros at the end count as significant. So we have 3, 6, 7 Sig Figs in the number in D. For questions 3 to 6, we're going to follow standard protocol. We're going to write down the calculator answer, then go back and do the Sig Figs. I've gone ahead and written down the calculator answer for each of these problems. These are combination problems, so we need an extra focus on determining the correct number of Sig Figs. Here in question 3, we see that we're going to have to determine the value of this number first and then multiply it by 2. It's the meaning of the parentheses. When we're doing addition and subtraction, we want to count decimal places. So we see we have 3 decimal places here. This goes out to the thousandths place. This one only has 2 decimal places, or it goes out to the hundredths place. So our answer for this intermediate value would only be allowed to have 2 decimal places. And we see that here, if we line up the decimal point, we see in this intermediate value that there would only be 2 significant figures justified. The second number only contains 1 Sig Fig. So when we look at the numbers that lead into our final result, we have a number in which 2 Sig Figs are justified, and a number in which 1 Sig Fig is justified. So we're limited to the least number of sig figs. Our final answer can only justify one sig fig. So our final answer is expressed as -2. A quick note, we could have known immediately that there would be only one sig fig in our final answer, because we knew we'd have at least one sig fig in this result. We know that there's only one here. We could have just skipped to the final answer by noticing the one sig fig, but I wanted to show this process as well. The second problem is also a combination problem. We need to consider the number of sig figs appropriate for the first result and the number of sig figs that are going to be appropriate for the number it's multiplied by. In the second number, there are 3 sig figs. Each of these numbers is a number 1 to 9, so they count as significant. However, we need to determine how many sig figs are appropriate to this result. We see that we can go out to the hundredths place. Okay, that's as far as we can go as a hundredth place, and that results in a value that should be expressed with 3 sig figs. This first part results in a number where we can justify 3 sig figs. There are 3 sig figs in the second number, so our answer is appropriately expressed to 3 sig figs. We look at the first number to be dropped. The first number to be dropped is greater than 5, so we add 1 to the preceding decimal column, and our final correctly reported answer is 8.51. Remember, in each of these problems, we write down our calculator answer first. We would be tempted to try and round this number and produce a result, but if we round early, we end up with rounding error. We do not round any numbers until we get to the end of our calculations. Write your calculator answer down first, determine the sig figs, and then do your rounding. In question 5, we have 2 results that are multiplied together. So we need to determine the sig figs in each of these results before we consider how many sig figs result from this multiplication. Looking at the first result, we see we have 2 decimal places here, just 1 decimal place in our second answer. So we can only use 1 decimal place. For this result, when we have 1 decimal place, that indicates that this is a number where we can justify 2 sig figs. Let's look at the second result. We have 3 decimal places here and just 2 in that second number. So we're going to be limited to 2 decimal places in this result. For this result, 2 decimal places indicates 3 sig figs are justified. Going back to our problem, we see that there's one result where 2 sig figs are justified. The second result, 3 sig figs. So for multiplication division, you count sig figs. Our final result can only justify 2 sig figs. So our final correctly reported answer is 28. In problem 6, as always, we write down our calculator answer. If this is not the result that you get when you enter this into your calculators, most likely what happened is you didn't consider the denominator as if these 2 numbers had parentheses around them. You need to divide by the product of these 2 numbers in the denominator. As far as sig figs, we need to consider essentially 3 different problems. We need to know the sig figs from this result, the sig figs from this result, and the sig figs from this result. Here we see we have 2 decimal places for each of these numbers, so our result can have 2 decimal places. Which corresponds, for this number, to 3 sig figs. And the second result in the numerator, we see a similar thing. 2 decimal places in each of the numbers in the addition, and therefore 3 sig figs that can be justified in that number. In the denominator, there's 3 sig figs in this first number and 3 sig figs in the second number. These leading zeros do not count as significant. So for our final answer, we have in the numerator numbers that are multiplied, each of which has 3 sig figs. So there's 3 sig figs appropriate for the numerator. There's 3 sig figs appropriate for the denominator. So overall in the problem, our answer is appropriately expressed with 3 sig figs. So we look at the first number to be dropped. It's greater than 5, which means we add 1 to the preceding decimal column. And this number becomes 78.7.